Classical mechanics is a branch of physics that deals with the motion of macroscopic objects, using Newton's laws of motion as its foundation. It provides the tools to predict how objects behave when subjected to forces and how they move in space and time. Classical mechanics has applications in everyday situations, from planetary motion to the behavior of machines, and is divided into several key subfields. Kinematics describes the motion of objects without considering the forces causing the motion. Key concepts include displacement, velocity, acceleration, and time. Dynamics studies the relationship between the motion of objects and the forces acting on them. This area is governed by Newton's three laws of motion. The first law, inertia, states that an object remains in its state of rest or uniform motion unless acted upon by an external force. The second law, F equals ma, asserts that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. The third law, action-reaction, claims that for every action, there is an equal and opposite reaction. Conservation laws are another important aspect. The conservation of energy principle states that energy cannot be created or destroyed, only transformed from one form to another. In classical mechanics, this involves kinetic energy, potential energy, and mechanical work. The conservation of momentum principle holds that in a closed system with no external forces, the total momentum remains constant. The conservation of angular momentum principle stipulates that for a rotating object, if no external torque acts on it, its angular momentum stays constant. Work and energy concepts involve the idea of work, which is defined as a force moving an object through a distance. Kinetic energy is the energy of motion, while potential energy is stored energy, such as gravitational potential energy. Harmonic motion describes systems like pendulums and springs, which exhibit oscillatory motion. Simple harmonic motion is a type of periodic motion where the restoring force is proportional to the displacement. Rigid body dynamics extends the principles of classical mechanics to objects that do not deform and involves the study of rotational motion, torque, and angular momentum. Gravitation is governed by Newton's law of universal gravitation, explaining the force of attraction between two masses. This law accounts for phenomena such as planetary orbits and the motion of celestial bodies. Fluid mechanics, despite dealing with fluids that are not rigid bodies, is also a subject of classical mechanics, including the principles of buoyancy, pressure, and viscosity. Classical mechanics assumes that objects move at speeds much slower than the speed of light, and that quantum effects are negligible, making it highly accurate for most everyday phenomena.